Hi, I'm Jodie from EdGenie and I'm going to be taking you through the October 21 A-Level Edexcel Pure 2 paper. I'm going to be doing a full paper walkthrough, telling you what I'm doing and why I'm doing it, and I'm going to be looking at the examiner notes to see what students commonly did wrong. Question 1 says, in an arithmetic series, the first term is 16 and the 21st term is 24. Find the common difference of the series. So we know that A equals 16. And we also know our 21st term is 24. So we know 24 is going to equal our first term plus n minus 1, so it's 21 minus 1, times your common difference. And that's what we're trying to find. So let's do a bit of rearranging here. If we do 24 take away 16, we are going to get 8. 21 take away 1 is 20. So D must equal 8 over 20, which is the same as 4 over 10, which is the same as 2 over 5. Part B says, hence find the sum of the first 500 terms of the series. So this formula is actually in our formula booklet. You might know this already off by heart, but it's this formula here. So make sure you're really familiar with the formula booklet so you can get what you need really quickly. So we want to find the sum of the first 500 terms. So we're trying to find this. So this formula is going to be the best one because we don't know L. L would be your 500th term, so I'm going to use this one. So a half times 500 times 2 times A was 16, plus n minus 1 times our common difference, which is 2 over 5 or 0.4. Then we can put this whole thing into our calculator. 2 times 16 plus 500 take away 1 is 499. So I have got 57,900. So the examiner report said that this question was done really well. They said the most common issue, quite weirdly, is that instead of doing 2 times A, they just put A. So I'm guessing that the students didn't copy the formula over properly from the formula booklet. Functions f and g are defined by, and they've written them here, state the range of f. So remember, the range is the values that are your output. So the domain is what goes in, the range is what comes out. So let's have a little think about what that graph looks like. So we know what a minus x squared graph looks like. It will be this kind of shape. But we're doing plus 7. So it's going to go like this. Like that, and it's going to cross at 7. So that means that the range of f, so the values it can take, f of x, is going to be less than or equal to 7. Part B. Find, and then we've got g of f of 1.8. So first of all, we can find f of 1.8. So let's do that first. So all we need to do is substitute 1.8 in for x here. So we do 7 minus 2 times 1.8 all squared. Put this into our calculator. And I have got 13 over 25. Or 0.52, whichever one we prefer. Then I want to substitute this value into the g function. Okay, can you see how I substitute it in place of x here? Put this whole thing into my calculator. And I have got 0.975. Part C says we want to find the inverse function of g, and it's going to be a bit fiddly because we've got two x's. So the first thing you want to do is write it as y equals, and then what we're trying to do is we're trying to rearrange it so that x is going to be the subject. So the first thing I'm going to do, let's give us some more space, is multiply both sides of the equation by 5x minus 1. Then I'm going to multiply this out. And then I want to get all of the terms that have x in to one side of the equation, all the terms that don't have x to the other side. So I'm going to do 5xy minus 3x from there equals y. So I've added y to both sides. Then I can factorize. So I'm taking out a factor of x. Then I'm going to divide both sides of the equation by 5y minus 3. I'm going to write it up here. Okay, that isn't our final answer though. So we now need to write g of this equals, and then we substitute back in our x in place of y. And that's your answer. So the examiner report said that this question was well answered, with the modal mark being full marks. So most students managed to get full marks. Part A was less well answered, where it was clear students had difficulty with the concept of range. So I have seen that before. Quite a lot of students do struggle with range. They get mixed up with the definition and they struggle with how to find it. But if in doubt, just sketch a graph. Question 3 is a logarithm question, so let's give it a go. So we've got log to base 3, and then we've got another log to base 3. Because we're taking it away, and they've got the same base, we can put them together as one log, and it will be 12y plus 5 divided by 1 minus 3y. And that equals to 2. So we then know that 3 to the power of 2 equals this. This is 9, and we can times it by 1 minus 3y. And this is going to be quite nice actually, because it's just a linear. Multiply this out. Add 27y to both sides, because we want it to be positive, so we don't want to take away 12y. You can, but it'll just be a little bit more tricky. That's going to be 39. Take away 5 from both sides. So therefore, y equals 4 over 39. I'm just going to put that into my calculator to see if we can simplify it. But I don't think we can't. So that's the answer. And then to check, we can substitute y into here and here. And if it gives us the answer of 2, then we know we got it right. So the examiner report says that the most common error that they saw is this first step, which isn't good because then it meant they can't get any of the other marks, apart from a few method marks. So instead of doing this expression divided by this expression, they did the whole log divided by this whole log. Question 4 says, given that theta is small and measured in radians, use the small angle approximations, so they're telling you what to do, to show that, and this is what we're trying to show, where A, B, and C are integers to be found. So remember, with a show that question, we literally have to show every single step. Otherwise, you're not going to get all the marks. Small angle approximation. So let's go to our formula booklet. And they are written here under trig identities. So let's have this handy. And there we go. That's going to help us. Right, we have 4 sine theta over 2. So we know that sine theta is approximately theta. So if we've got sine theta over 2, it's going to be approximately theta over 2. So we have got 4 times theta over 2. And here we have got cos squared. So when you see a cos squared, it's actually going to be easier. Instead of using all of this, we can rewrite cos squared as 1 minus sine squared. Because do you remember the identity? Sine squared theta plus cos squared equals 1. So that means cos squared equals 1 minus sine squared. And then, this is going to be a bit easier for us now. Sine squared theta is going to be theta squared. Multiply this out. This is going to be 2 theta plus 3 minus 3 theta squared. And actually, that's already the answer, isn't it? So let's just rearrange it so we can see what A, B, and C are. It's going to be 3 plus 2 theta minus 3 theta squared. So the examiner report said that students who realised that they could write cos squared as 1 minus sine squared did much better than the students who didn't, because then they had a lot of issues and they had to use the double angle formula. So always have a think, can I make my life easier instead of doing a really long method, especially when it's only 3 marks, because you don't want to be doing pages and pages of working for a 3-mark question. Question 5. The curve has this equation. Find dy by dx. So that's nice and easy. We multiply by the power and reduce the power by 1. So 5 times 4 is 20. 4 minus 1 is 3. 24 multiplied by 3 is 72. And decrease the power. 42 times 2 is 84. Here it's just going to be minus 32. And this one, imagine it was x to the power of 0. So you times it by 0, so that term disappears. Now we're finding the second derivative. So we're going to differentiate this. 20 times 3 is 60. Reduce the power by 1. 72 times 2 is 144. Reduce the power by 1, plus 84. Part B says, verify that C, so this curve, has a stationary point at x equals 1. So for that to happen, it means that when x equals 1, dy by dx will equal 0. So let's check that's the case by substituting into here. We can put the whole thing into our calculator, but I know that like 1 cubed and 1 squared is going to be 1, so I'm not going to put that in. I'm just going to put 20 minus 72 plus 84 minus 32, and I've got 0. So then I can say, therefore, stationary point at x equals 1. Show that this stationary point is a point of inflection. So what that means is it's where the curve like changes direction. So for example, we don't know exactly what this curve looks like. It will look something like this. This would be the point of inflection. So instead of when it keeps going down, it then starts changing direction. So if this is a point of inflection, then when we substitute x as 1 into here, we know that that's going to equal 0, and it will do. So what you want to do is pick a point just before and just after. So instead of x equals 1, you could pick x equals 0.9. and just after as well. So you picked x equals 1.1, anything like that, just slightly before, slightly after. And we're going to substitute it into here because this is our change in the gradient. So we're going to do 60 times 0.9 squared, 144 times 0.9 plus 84. That's going to give us that gave us a 3. So that's a positive number. Let's see, hopefully this one will be negative. And I actually left this on my calculator, so I'm just going to change the 0.9 to 1.1. And I've got minus 9 over 5. So because this one's positive, this one's negative, I can then say, read my question, it's going to give me the answer, show that the stationary point is a point of inflection. So I can say, therefore, stationary point is a point of inflection. So when you're looking for a conclusion, always look back at the question and that will basically give you your conclusion. So the examiner report says a significant number of students gained no marks on that last part of the question as they assumed that when both the first and second derivative equals 0, then the point is a point of inflection. So that's not correct. You needed to show just before and just after that the change in the gradient, so the second derivative, is going to change direction. Question 6, so we have got this shape here and it says this is a design for a logo. And they've given us lots of information here, but it's all written on the diagram anyway. Given that the size of angle COD, so this angle here, is theta radians, write down in terms of theta angle AOB, so this angle here. And that angle is going to be exactly the same as this angle. So we can do, because it's like on a straight line, which would be like 180, but we're working in radians, so in this case it's going to be pi. So we are going to do pi minus this angle here, which is theta. That will give us these two angles. And then, because we only want one of them, we're going to divide it by 2. Part B. Show that the area of the logo is this. So remember, our formula is going to be half r squared theta. And we've got 3 different parts because we've got this part here, this part here, and this part here, but 2 and 3 are going to be the same. So let's do 1 first. So area is going to be half times our radius squared, but our radius is 2r. Times by our angle, which was theta. Let's simplify this a little bit before we do the next one. That's going to be half times 2 squared is 4, r squared is r squared. This can cancel out to be 2, so that's going to be 2r squared theta. Second one, same formula. Half times our radius squared, and our radius here is just r, times the angle, which we worked out to be pi minus theta all over 2. Let's multiply this out a bit. We've got the half and a half, so it's going to be over 4. So it's going to look like this. So our total area, remember 3 is going to be the same, so this is also going to be 3. So I'm going to add this one twice. I'm going to have 2 r squared theta plus, I'm not going to add it twice actually, I'm just going to times it by 2 because that's going to be a bit easier. Now let's simplify it and hopefully it's going to look like this. Multiply this out, we are going to get this. Now I'm going to multiply all of these parts because then I'm hoping we can then factorise it the same way that they've asked us to. So this would be pi r squared minus theta r squared, and these two terms are over 2. Now go back to the question. We wanted a half r squared, so let's see if we can take out that factor. So a half r squared, what would we need to times it by to get 2r squared theta? We would need to times it by 4 theta, wouldn't you? Because a half times 4 would be 2. Plus, this would need to be multiplied by pi to get this. And this would need to be multiplied by theta, minus theta to get this. So let's simplify that again. 4 theta minus theta is 3 theta plus pi. Let's check that this is the answer. Yeah, it is. So we know we've got that. Now find the perimeter. That was only 2 marks. I feel like we did a lot of work for that. Find the perimeter of the logo, giving your answer in its simplest form in terms of r, theta, and pi. Okay. So we're going to need to know this length, and this length. Let me just clear some of this. So remember, to find the arc length, you do the angle times by the radius. So this side here is going to be 2r times our angle. And this one here is going to be r multiplied by our angle, which was pi minus theta over 2. And the same over here is going to be r times pi minus theta over 2. Right, we also know that if this length here is 2r, this length here must be r, because that's also the radius. So just this part here is r. So we have 1, 2, 3, 4 r's. Then we need those 3 other lengths we found. So this was 2r theta, this one here. Plus 2 lots of this one here. So it's r times pi minus theta over 2. Right, let's multiply this all out. This is going to be cancelled like that. So we're going to have r pi minus r theta. So can we simplify this again? These two can be simplified. So we're going to have 4r plus r pi. So this one and this one is then going to be r theta. Did it want it in a certain format? No, it just said simplest form. So this here is my answer. So the examiner report said that a common error was in part C. Let me show you when we're finding the perimeter, that students forgot to add the r, this r, this r, and this r. So they only found out the 3 arc lengths, but didn't add the other lengths. Question 7, and it says at the top, In this question, you should show all stages of your working. Solutions relying entirely on calculator technology are not acceptable. So what they're saying there is you can't just put the whole integration or the whole differentiation or the solving into your calculator just to get the answer. You need to actually work it out yourself. So we have got a curve and we've got a line. We can see it's a tangent at this point. The line L is a tangent. Use differentiation to find the equation of L, giving your answer in this form, where M and C are integers to be found, and it's 4 marks. So there's 2 things we need for an equation of a line. We need a coordinate, which we've got here, and we also need a gradient. So we need to try and find the gradient of this line. Because we know it's a tangent at this point, if we differentiate the equation for this curve and then we can substitute in 5, that's going to give us our gradient at this point. So let's have a go at that. So dy by dx. So I'm differentiating this here. So it's going to be 3x squared minus 20x plus 27. And my x value is 5. So substitute 5 into here. So 3 times 5 squared minus 20 times 5 plus 27 equals 2. So now I've got my gradient and I've got a coordinate. I can do y minus 13. So plus equals the gradient times x minus 5. So this would be our answer, but they want it in this form. So we're going to have to do a bit of rearranging. Let's multiply that 2 out. So that means y is going to equal 2x, take away 13 from both sides, minus 23. Part B says, hence, verify that L meets C again on the y-axis. And it's only 1 mark, so it shouldn't take too long. Let's have a look. So they're basically saying, prove that they cross here. So at this point, we know that x is going to be 0. We don't know what the y-coordinate is, but we know that x is going to be 0. So let's find out what the y-coordinate would be on this curve. Well, we can see straight away it's going to be negative 23, isn't it? Because 0, 0, 0 minus 23. Because we're verifying, I'm actually going to write that out. I'm going to do it up here only because otherwise I'm going to be scrolling up and down the whole time. So 0 cubed minus 10 times 0 squared. Obviously, we already know what this is going to be. Equals minus 23. So that value in there is minus 23. Let's check that that works for this. Oh, it does. Okay, so therefore we verified. So now we can say both C and L pass through 0, negative 23. Part C. Use algebraic integration to find the exact area of R. So we're finding the area of this. So we're going to want to do the integral of the curve minus the integral of the line. And it's going between this value 0 and that value is 5. So we're going to do 0 to 5. It was x cubed minus 10x squared, was it? Let's check. Yep, plus 27x minus 23. Now you could do minus the integral of the line as a completely separate integral, or we can just do it together and just make sure we minus the whole thing. So it's 2x minus 23. I'm going to simplify this before I actually integrate. (27x minus 2x) minus 23, then take away another minus 23. So that's quite nice. Those are going to cancel out. Now let's integrate. Remember, you add 1 to the power and divide by the new power. And we don't need to put plus c because we have our limits. Then substitute 5 into here. Substitute 0 in, but can you see how all of these terms are just going to go to 0? So I'm not going to bother writing all that out. Put this all into our calculator. And we've got 625 over 12. So the examiner report said that in part B, most students understood the need to show the y-intercepts were the same for both, but often candidates struggled to write an adequate conclusion to verify that they meet again and hence lost the mark. Question 8, so we have this curve for the equation, show that dy by dx equals this. So this is implicit differentiation, which can be a little bit fiddly, so let's have a go at it. So we're differentiating with respect to x. So px cubed, that's going to be, so remember that p is just a number, a constant. So px cubed differentiated will be 3p x squared times by the power, reduce the power by 1, plus, here we've got qxy. So if I differentiate it with respect to x, I'm going to times by the power, which is 1, and then reduce the power by 1. So it's going to be x to the power of 0, so we're just going to have qy. Then I need to differentiate it with respect to y. So that's when it gets a little bit trickier, because differentiating with respect to y would be qx. But because we've differentiated with respect to y, we need to multiply that by dy by dx. Then we have 3y squared. So differentiating that would be 6y, but again, we need to times it by dy by dx. Differentiating 26, that's just going to go to 0. Now we can do a little bit of rearranging. So I'm going to take these two terms separate, so onto the other side, so that we're just left with this. So if I take away these two terms from both sides, I will get so minus 3px squared minus qy. Then I'm going to factorise dy by dx. And I'm going to have qx plus 6y. Divide both sides by this, and we are left with now this might not be the format they want, so we might need to do some multiplying by negatives. So let's have a little look. Oh, it's fine, because A is -3 and B is going to be -1. Okay, we could, if we wanted to, multiply the numerator and denominator by -1, so then we would get this. but they're the same, so it doesn't matter whichever one you prefer. Part B. Given that point P, -1, -4, lies on C, and the normal to C at P has this equation, find the value of P and Q. So if it has this equation, then we can find out the gradient, and then we can do the negative reciprocal, and that will be our gradient of the tangent. So let's do that first, actually, and then we can look at that coordinate. So I'm going to rearrange this, and it's going to be 26y equals -19x minus 123. We don't actually care about that term, we just care about this. So y equals -19 over 26. So this is going to be our gradient. That's going to be of the normal. So the gradient of the tangent is going to be positive 26, that looks like a 20, over 19. Right, so now we need to substitute in. So we've got a few different things to substitute in. This is our gradient when x is -1 and y is -4. And we can also substitute -1 and -4 into here. So we're going to do both of those things. So I've just put these here again to help us, and we know it's -1, -4. So let's substitute in here first. -1 cubed is going to be negative, because you've got negative times negative times negative. X is going to be -1 times -4, so that's going to be +4. -4 squared is going to be +16. So let's just simplify this again. 3 times 16 is 48. So let's take away 48 from both sides of the equation, and we have this equals -22. So this is our first equation. Next equation, I am going to substitute this in here and then these values into here. So 26 over 19 equals -3p times x squared. So -1 squared is going to be +1. So this times 1, it's just that, minus q times -4. So that's going to be actually positive 4q. Q times -1, so it's -q, plus 6 times -4. Well, 6 times 4 is 24, so that's going to be -24. Now let's rearrange this. So I'm going to multiply both sides of the equation by -q minus 24. I'm thinking actually I might multiply both sides of the equation by 19, just because then I'm not going to have any fractions, and then I can multiply the 26 out. So I'll get -26q. 26 times 24 is 624. 19 times -3 is -57. 19 times 4 is 76. And I know that these are massive numbers, but at least I don't have any fractions. Now, should we... yeah, let's add 26q to both sides of the equation. (76 plus 26 is 102. Okay, so this is our second equation. Whew! Should we simplify it? Nah, let's just leave it, it's fine. Right, we have equation 1, equation 2. we have got negative p, and here we've got negative 57p. So if I multiply all of these terms by 57, so I'm going to do equation 1 times 57, I'm going to get minus 57p. 4 times 57 is 228q. Minus 22 times 57 is minus 1,254. So now I can do this equation, take away this equation. Or should I do it the other way around? Doesn't matter. Equation 2 minus equation 1. So minus 624, take away minus 1254 is 630. Looking at the p's. So minus 57 minus negative 57 is 0, which is what we wanted. 102q minus 228q is minus 126q. So therefore, 630 divided by minus 126 is minus 5. How nice. Then I'm going to substitute it back into here because that's going to be the simplest one. We have got, let's change colour, minus q plus 4 times negative 5 equals negative 22. This is minus 20. Add 20 to both sides of the equation. So p must equal 2. Whew, hopefully we're done. Let's have a look. Find the values of p and q. Yeah. The examiner report says many candidates gained some credit in this question, but few gained full marks. And the main issue was in this part here. So when they're differentiating this, they struggle to do both parts separately. Question 9, this looks quite confusing, but it's 3 marks, so hopefully it's not going to be too tricky. We are finding the sum of all the terms from 2 to infinity. So if we start with n equals 2, we can then find our first term, which is a, that's what we call it. So 3 over 4 all to the power of 2 times cos 180 times 2. So I'm going to put all of this into my calculator. I'm going to check that my calculator is in degrees first because we're doing degrees here. So 180 times 2. And I've got 9 over 16. So that's A, my first term. Let's have a look because we also need to find our common difference, our common ratio. If n is now 3, let's see what that's going to look like. I've left this on my calculator so I can just change the squared to a cubed and 180 times 3. So that's given me minus 27 over 64. So now let's have a look. Minus 27 over 64 divided by 9 over 16. That's going to give me minus 3 over 2. So that means our common ratio is minus 3 over 2. So to get from this term to this one, we times by negative 3 over 2. To get to the next term, we times by negative 3 over 2. So our sum to infinity is going to be a, which is 9 over 16, over 1 minus our common ratio, this one. Let's put that into our calculator. And we've got 9 over 28. Woohoo! So it was a show that, so we got it. So the examiner report said that this question was fairly well answered by a number of candidates who understood that they needed to use the sum to infinity, but a sizable majority made little or no progress. So whenever you see here up to infinity, you should be thinking, right, that's the sum to infinity formula. Question 10, the time t seconds that a pendulum takes to complete one swing is modelled by this formula, where L meters is the length of the pendulum and A and B are constants. Show that this relationship can be written in this form here. Okay, so we want to get from this to this. So let's take logs of both sides. So it's t equals AL to the power of B. And because it's a show that question, I am literally going to show every single step. So I can rewrite this, let me show you, using our log rules. Because it's A multiplied by L to the power of B, that's the same as A plus, like that. And then when you've got a power in the log, you can put that power in front of the log and we will have and then I think it just wanted it the other way around, didn't it? So let's swap these two terms. Okay, let's check. Yeah, we got it. A student carried out an experiment to find the values of the constants A and B. The student recorded the value t for different values of L. Figure 3 in here shows the linear relationship between this log and this log for the student's data. The straight line passes through the points, this coordinate and this coordinate. Using this information, find a complete equation for the model in this form, giving the values of A and B to 3 significant figures, and it's 3 marks. So, a bit tricky to see this, but to find the value of B, we're actually going to look at the gradient of this line, because look at the equation up here. Because it's B multiplied, so it's kind of, imagine if it was y equals bx plus c. That would be quite easy to see, wouldn't it? So we're going to do the gradient. The other clues where they kept saying it's a linear relationship, it's a straight line. So let's have a go. So it's minus 0.7 and 0. And 0.21 and 0.45. 0.45. So our gradient, which will be B, is the change in y. Doesn't matter if you do this one, take away this, or this, take away this. I'm going to do, don't know why I put that bracket, 0.45 minus 0 divided by 0.21 minus negative 0.7. Put this into our calculator. And I've got 45 over 91. And I know it's said to 3 significant figures. I've not forgotten that. But if I put this at 3 significant figures now, then my value for A isn't going to be right. Right, let's substitute this in. So this here, negative 0.7, that's going to be your, like the x-axis. So that's going to be log to base 10 of L. And then the 0 is going to be log to base 10 of t. So we can substitute this in. So it's going to be 0 equals b multiplied by negative 0.7 plus log to base 10 of a. So this is minus 9 over 26. So I can rewrite this as 9 over 26 equals log to base 10 of a. So this means that 10 to the power of 9 over 26 equals a. 10 to the power of my answer. And I have got a equals 2.22. And that's to 3 significant figures. And b, let's put that into our calculator now. So 45 divided by 91, and it's 0.495 to 3 significant figures. But we still haven't answered the question because it said find the complete equation in this form. So we have to write that back out. So t equals al to the power of b. Now we're done. Part C says, with reference to the model, interpret the value of the constant a. So t is our time, L is our, what was L? L is meters of the length of the pendulum, and a and b are constants. So that means if I look at this equation, that's time, that's length of the pendulum. So imagine if that b was 0, this would then be 1. So t would equal a. So that means that a must be the time for every 1 meter of the pendulum length. I'm going to put time of swing . For 1 meter of pendulum length. So the examiner report said that some students were able to use simultaneous equations for this part B. So if they didn't realise that it was the gradient, instead they made 2 simultaneous equations, but there were a few errors seen here because of course there's going to be a lot more fiddly than just finding the area. Question 11, and this is a modulus question, so let's have a go at this. Shows the sketch of the graph. Okay, so we've got this graph where k is a positive constant. Now we want to do a translation. But on our translation, they want us to find the maximum point and where the graph cuts the coordinate axes. So it's really important that we know these coordinates, and then once we do our reflection and our translation, we'll be able to find out what that is. So this value here, this is going to be where it crosses the y coordinate, so x is going to be 0. So it's going to be y equals, that's going to be 0, the modulus of negative 3k. So that means that this coordinate is going to be 0, 3k. Because it's going to be positive, isn't it? This coordinate here. So if we just had this line, forget about the modulus, and we had y equals 2x minus 3k, where would that cross the x-axis? So it would cross when y equals 0. So it'd be 0 equals 2x minus 3k. So 3k equals 2x. So therefore x equals 3k divided by 2. So let's get rid of that. This coordinate here is therefore going to be 3k over 2. And what did we say our y was? 0, of course. So that's our coordinate. Now let's have a look at what we're doing. So we've got a minus here and it's outside the function. So that's going to be affecting the y coordinates, a reflection. So if it's affecting the y coordinates, it's going to be a reflection along the x-axis. Then we have this, and this is going to be a translation, and it's moving up the y coordinates. So 0 in the x direction and k in the y. So let's have a go at drawing that. We can do our reflection first. So our reflection is going to look like this, isn't it? And then we're translating it up k units. So it's going to be up here, and it's going to look like this, and like this. So we don't actually need this one anymore. Let's rub that one out. That was just to help us. So let's think about all our values. So this value here, we were at 3k over 2. We reflected it, so the x-coordinate was still 3k over 2. The y-coordinate was still 0. And then we translated it by k, so it's going to be 3k over 2k. Because we've gone from 0 up to k. Then let's have a look at this coordinate here. Sorry, lots of scrolling up and down. So we were at this coordinate, then we reflected it, and we were down here at 0 minus 3k. And then we translated up by k units, so we're going to be at 0 minus 2k. Then let's have a look at these two intercepts. So we can do that by looking at the equation. So we have this. Let's rewrite that, so that's going to help us. F of x equals, I'm going to write y equals. What was it? 2x minus 3k? So when y is 0, so this part here is going to be when it's just 0 equals k minus this. And this part here, let me write it over here so we can got some space for working, is going to be when it's minus 2x minus 3k. That sounds a bit confusing. Let me explain. So because this is the modulus one, so it's gone from up here, this is the line 2x minus 3k, and then we've reflected that, so it's gone to minus 2x minus 3k, which is this line here. So we put the minus outside the 2x minus 2k, so we're basically taking away minus 2x minus 3k. So this would be k plus 2x minus 3k. And this one here, 0 equals k minus 2x plus 3k. So this is going to simplify to 4k. So 2x equals 4k. So x equals 2k. Then look at this one. Minus 3k plus k is minus 2k. So, scroll down a bit. 2k equals 2x. So then k equals x. So this one here is at k. And this one here is at 2k. Oh, right, part B. Find in terms of k the sets of values of x for which this is greater than this, giving your answer in set notation. So that's going to be important. Let me just rewrite that down here, so I'm not going to have to keep going up and down the page. So there's going to be two solutions. One of them is going to be when we're looking at this line here, And the other one is going to be when we're looking at this line here. So it's the same as what we did here with the extra negative. So the first one is going to be when it's minus all of this. And the second one is going to be when we're basically minusing this minus, so it's going to be like plus. Now we can simplify these. Let's collect all the like terms. 3k plus k is 4k, plus that other k is 5k. X's, so if I add 2x to both sides, I get 3x. So I have this. I know it's not in set notation, we'll do that in a minute. Here we have k minus 3k, so that's minus 2k, and the 2x. Let's take away x from both sides, and let's add 2k to both sides. And we get this. So when we write this in set notation, we are going to write, it's going to look like this. X is going to take all the values for x is less than 5k over 3. And x is also going to take all the values for x is greater than k. So part C says, find in terms of k the coordinates of the minimum point of the graph with this equation. So we've got the f here, so we're looking at this function. So when we sketch this function, let's have a look. This was our maximum, so we had a maximum at 3k over 2 and k. I'm going to write part C here so I don't have to keep scrolling up and down. And that was a maximum, but we're now looking for a minimum, which makes sense because we're multiplying it by a negative. Right, so this was f of x. Now if we're looking at a half x, I am going to multiply the x coordinates by 2. Okay, so this was f of x. Now I'm going to find f of half x. So my coordinate is going to be 3k, k. So it's not going to affect the y coordinates. Then I now want to do a stretch in the y direction of minus 5. So I'm going to do minus 5 f of a half x. X coordinate is going to be 3k. Y coordinate is going to be minus 5k. Yeah. Then, it's doubting myself then. Then we've got 3. So we're doing 3 minus 5 f of a half x. So we're doing a translation up 3 units in the y direction. So it's going to be 3k for our x. And then it's going to be 3 minus 5k for the y-axis. So the examiner report said, in general, part A was poorly answered, with many candidates seemingly unfamiliar with sketching modulus functions. The majority of candidates scored at least 1 B mark for their upturned V, but the V shape was occasionally seen, typically scoring no marks. So make sure when you're doing your revision that you get really comfortable with sketching modulus graphs. Question 12 says, use the substitution to show that. And they're literally telling us what to do, so that is great news. So let's have a go at it. If u equals 1 plus the square root of x, then u minus 1 equals the square root of x, and x equals u minus 1 squared. So now we can find dy. So dx by du, if I differentiate this, would be 2 lots of u minus 1 times by 1, which is the differential of u, but don't need to write that. So then I can substitute this in. Are we going to change the limit straight away? Yeah, let's do that. So instead of 16, we are going to have 1 plus the square root of 16. So substitute in here. And down here, we're going to have 1 plus the square root of 0. We could work that out straight away, but I'm just putting it there to show you. X. So x is u minus 1 squared over 1 plus the square root of x. We know that that's going to be u. And we're going to multiply that by dx, which is 2u minus 1 times du. Then let's just rearrange this. 1 plus the square root of 16. So the square root of 16 is 4 plus 1 is going to be 5. This is going to be 0. No, it's not. It's going to be 1. That's going to be 1. Then multiply this out. We are going to have 2 u minus 1 cubed. And when I say multiply it out, I mean this with this. All divided by u with respect to du. Okay, part B is hence show that. So we're basically working out our integral and we want it in exact form. So we're not going to just be able to put the whole thing into our calculator at the end, unfortunately. So the easiest way to do this is actually just going to be to multiply it out. U minus 1 cubed, you might know this from your Pascal's triangle, from your binomial. We can just work that out all in one. That's going to be u cubed minus 3u squared plus 3u minus 1, all divided by u times du. So, cancel this out. U cubed divided by u squared. 3u plus 3 minus 1 over u. So that's where we're going to have our ln at the end, isn't it? Right, let's integrate. Add 1 to the power, divide it by the power. Remember, when we differentiate 1 over u, that's going to be ln u. Substitute 5 into here. Now substitute 1 in. But when I'm substituting 1 in, like I know this is going to be a third, so I'm just going to put a third. And like this will be negative 3 over 2. Now let's do some simplifying. So these 3 terms I'm going to put into my calculator all in one go. Three times 5 squared over 2. Plus 3 times 5 is 115 over 6. Yeah, minus ln 5. These 3 terms, if I put them into my calculator, 3 is 11 over 6. So it's going to be minus 11 over 6 minus ln 1. So it's going to be plus. Then, let's simplify this a bit more. 115 over 6 minus 11 over 6 is going to be 104 over 6 times up by 2. It's just going to be 104 over 3, isn't it? That's nice. And here, let's think we've got minus ln 5 plus ln 1. So that's going to be the same as minus ln 5 times 1, which is just going to be minus ln 5. So it's going to be the same as minus 2 ln 5. And that, hopefully, will be our answer. Let's check what format they wanted it in. Yeah, so that's good because we've got ln 5. So we can be pretty confident that we got that right. The examiner report says, unfortunately, a number of students attempted a method of integration by parts or some kind of product rule and therefore gained no marks here. So I know it's tricky to know, isn't it? But when you can kind of think, actually, it's just going to be quicker and easier to multiply it out and simplify it, then always do that. So before you kind of start a question and potentially go off on a tangent, always think, is this the easiest and simplest way that I can be doing this? Question 13 is a parametric equations question. So we are finding dy by dx, we've been given x and we've been given y. So remember, dy by dx equals dy by d theta divided by dx by d theta. So we can work out dy by dx, dy by d theta, and then divide it by dx by d theta. So let's have a go at differentiating this. We're going to use the chain rule. So it's going to be 3 cosec squared, because I'm timesing and then reducing the power, times the derivative of cosec theta. So we are going to go over here to our formula booklet, and this is actually in our formula booklet. Here we go. So it's minus cosec x times cot x. Then we're going to divide this by dx by d theta. So I'm doing the derivative of sine 2 theta, and that's going to be 2, from where I differentiated my 2 theta, times the differential of sine, which is cos 2 theta. Then let's simplify it just a little bit. So the numerator can be minus 3 cosec cubed times cot divided by 2 cos 2 theta. So that was part A. Part B says, hence find the exact value of the gradient of the tangent to C at the point where y equals 8. So if y equals 8, we then need to find out what theta must be. So let's do 8 equals cosec cubed theta. Cubed root of 8 is 2. And cosec is the same as 1 over sine. I don't know how you like to remember this, but I always look at the third letter. So if it's an S, it's sine. So that means that sine theta equals a half. Then I can get my calculator out. If sine theta equals a half, do I need to be in radians? Yes, I do. So I'm going to change my calculator to radians. Sine to the minus 1 of a half. So let's write it up here. Theta equals pi over 6. And are there any other values? We're between 0 and pi over 2, so that's going to be it. This is my theta value. So I'm finding the gradient, so I want to substitute this into here. Which sounds easy, but it's a little bit fiddly because we've got a lot going on. dy by dx equals minus 3, and then we've got cosec again. So that's going to be 1 over sine cubed, and then it's pi over 6, times cot, the third letter is t, so it's 1 over tan pi over 6, all over 2 cos 2 times pi over 6. Then let's put this whole thing into our calculator. Be careful, make sure we don't type anything in wrong. Sine cubed, okay. 1 over tan. Whew. Cos 2 times pi, 2 times pi over 6 equals, well, I've got minus 24 root 3. Does it say anything about the exact value? Okay, so that looks good. So the examiner report said that the biggest issue was differentiating cosec cubed theta, and they didn't realise that differentiating cosec is minus cosec cot x, even though that's in the formula booklet. So that's a really frustrating mistake to make. Make sure that you are really familiar with the formula booklet so you don't make issues like that. Question 14, the end is near. So we have water flows into at a constant rate into a large tank. Tank is a cuboid with all sides of negligible thickness. So they're saying it's thin enough that we don't care about it. The base of the tank is 8 by 3 and the height is 5. There is a tap at point T at the bottom of the tank. Okay, so the water can flow out. At time T minutes after the tap has been opened, the depth of the water in the tank is h meters. Water is flowing into the tank. Oh, it's going into the tank. Okay. At a constant rate of 0.8 meters cubed per minute. Water is modelled as leaving the tank at a... Okay, right. So some goes in, some comes out. At a rate of 0.1 h meters cubed per minute. According to the model, show that this is true. So, a few different things that we're going to need to find out. First of all, let's think about the volume. So the volume is going to be 3 times 8 times h, so the volume of the water. So 3 times 8 is 24, so it's going to be 24h. That means dV by dH is going to be 24. We also know the water is flowing into the tank and out of the tank. So the volume with respect to time, the change in the volume with respect to time is going to be 0.48 minus 0.1 h. Whew, bear with me. We're trying to find dH by dt. So everything I've written here, let me copy down there. We want dH by dt. So we can do dV by dt times by dH by dV. Because can you see how those two would cancel? Then you have dH by dt. dV by dt is this. dH by dV is going to be 1 over 24. Okay, so let's just have another look at what they want it to look like. So they want it to look like this. Okay, let's multiply everything by 24, but let's just be a bit careful because this is actually all multiplied by 1 over 24, isn't it? So we'd have 24 dH by dt equals 0.48 minus 0.1 h, but we wanted this to be 5. So let's multiply everything by 50. 24 times 50 is... I might just make a note here that I'm multiplying by 50. 0.48 times 50 is 24. And this is then going to be 5, which is how I knew I was multiplying it by 50, because the question wanted 5h. So we've done it. We've done part A. Given that when the tap was opened, the depth of the water in the tank was 2, show that according to the model, this is true. So what they're saying is T equals 0, H equals 2. According to the model, show this. So I'm going to have to integrate. But I want all of my H terms at one side of the equation, and then I want dt to be on the other side. So let's rearrange this. Then I can integrate. So if you're not sure how to integrate this, you can actually take the 1,200 outside of the integral, and then we're going to have 1 over 24 minus 5h, which might be easier. So integrating this, I'm going to get 1,200 times by 1 over minus 5 from here times ln 24 minus 5h. And that's going to equal the integral of this, which is going to be t, plus some constant c, which is why they told us t equals 0 when h equals 2. So let's substitute in those values. Five times 2 is 10. So let's simplify this a bit. That's going to give us minus 240. ln 24 minus 10 is 12. No, it's not, it's 14. Equals C. So what form do they want it in? Let's have a look. Show that according to the model, it looks like this. So quite a lot of rearranging. So let's substitute back into here. We're going to have minus 240 C, which is right, a lot of rearranging to do. So t equals, if I add this, this again, it can be written. So because we're taking away, I can write this as divide both sides by 240 will give us this. And that's going to be helpful because then I can take the exponential because we want h to be the subject. So I'm going to put this as e to the power of t over 240 equals 14 over 24 minus 5h. Multiply by 24 minus 5h. This actually is the same as, let me show you, 24 minus 5h multiplied by this. But I'm not going to multiply that out. I'm going to now write it like this. Because that is the same as 14 times e to the minus t over 240. So let's see if we're nearly there. What did they want it to be like? A plus. Okay, that's good because we have got a constant. So I want the 5h to be positive. So let's add 5h and let's take away this. Then I'm going to divide everything by 5. equals h, and did it say anything about being integers? No, it just said about being constants. So let's hope we got that right. Next part, part C. Determine according to the model, given that the tap remains open, so T is going to get bigger and bigger and bigger, whether the tank will ever become full, giving a reason for your answer. So full is when H is going to be 5 meters. So let's see, as T goes to infinity, let's see what happens to this model and see if this is ever going to be larger than 5. So we're going to have 24 over 5. This term here, so as T gets bigger and bigger and bigger, you're going to have the exponential to the power of negative infinity. So that is going to go closer and closer to 0. So at infinity, this will be 0. Therefore, this will also be 0 because we're multiplying by 0. 24 divided by 5 is 4.8. So H equals 4.8, although it doesn't actually equal. Let's say H tends towards 4.8. So no, it's never going to be full, is it? Check we answered that. Well, the tank will become full. Yeah. The examiner report said this question proved challenging for the majority of candidates, with many not answering it at all. For those who did attempt a response, part A was reasonably well answered, with many gaining at least 1 mark, but quite a few then failing to correctly apply the chain rule and complete the proof. A massive well done if you made it this far. We are on our last question. So express this in this form. Okay, so we know how to do this. Let me just write out the question again down here. We had, can't even remember, 2 cos theta minus sine theta. And we want it to be our cos, was it theta plus, yeah, theta plus alpha. So the first thing we want to do is look in our formula booklet to see our double angle rule, which is over here. So it's cos A, cos B, and then it's going to be minus sine A, sine B. So we can rewrite that as R cos A, this one, cos B, minus sine A, sine B. Okay, so let me just write this as well so we can see what we're doing. So we can see from this that 2 must be R cos alpha. Can you see that? So we've got the cos theta there. So 2 must equal R cos alpha. Then minus sine theta. So we've got the minus sine here. So that means that 1, because we don't have any other term, must equal R sine alpha. And then from this we can find our R value and we can find our alpha. So there's different ways of doing this. I do it based on sine squared plus cos squared equals 1, because I know 2 over R equals cos, and 1 over R equals sine. So I therefore know that 2 over R all squared plus 1 over R all squared equals 1. So then multiply this out, I have 4 over R squared plus 1 over R squared equals 1. Multiply everything by R squared. So So we can see that r is going to be the square root of 5. Some people just memorize it and they just say it's this squared plus this squared, but I just wanted to show you how to do it. You can also do it using trigonometry. Yeah, there's a few different ways, it's up to you. So now I want to find this value for alpha, and to do that, I am going to do r sine alpha divided by r cos alpha, and that's going to equal 1 divided by 2. The r's cancel out, and we're left with tan alpha equals a half. Tan to the minus 1, make sure your calculator's in radians. And I've got not a nice number, 0.464. So let's just check. And the question said 3 decimal places. Good, so exact value of r, got that. Alpha in radians, 3 decimal places. Perfect. Figure 6 shows the cross-section of a water wheel. The wheel is free to rotate about a fixed axis through the point C. The point P is at the end of one of the paddles of the wheel. Here we go. As shown. And the water level is assumed to be horizontal and of constant height. So the water level's like that, it's not moving. The vertical height, h meters, of P above the water level is modelled by this equation, where T is the time in seconds after the wheel starts rotating. Use the model to find the maximum height of P above the water level and the value of T when its maximum height first occurs, giving your answer to 1 decimal place. So what I'm going to do first is have a look at this and see if it looks similar to any of this. So it does look similar to this, doesn't it? So here we've got 2 cos theta minus sine theta. Here we've got 4 cos, and then I know we've got 0.52. So this is the same as 3 plus double what we had here. So it's like 2 root 5 cos, but it's not going to be alpha. It's going to be 0.5t plus, it's not going to be theta, it's going to be 0.5t plus alpha. So it's going to be this. Let me write that out again here. Let's put our value. That's better, isn't it? Is that the same? Yeah, perfect. So we can see straight away what our maximum height is going to be, can't we? Because this, the maximum this can be, is going to be 1, because it's the cos graph. So max is going to be 3 plus 2 root 5. And then, so that was part I. Part I says, the value of t when its maximum height first occurs, giving your answer to 1 decimal place. So when this is 1, let's put that equal. So cos 0.5t plus 0.464, and I'm putting that equal to 1. Cos to the minus 1 of 1. So we're going to have 2 values if you think about your cos graph. It's going to be here at 0 and it's going to be here at 2 pi. So 0.5t plus 0.464 can equal 0, or it can equal 2 pi. This one, straight away, I can see if I work this one out, t is going to be negative. So t is going to be negative, so can't do that one. This one we can do. So if we rearrange this, we're going to get 0.5t equals 2 pi minus 0.464. Divide both sides by 0.5. And I'm just going to put it all into my calculator together. We get 2 pi minus 0.464 divided by 0.5 equals 11.6 seconds. Let's just check the question. Where is it? Here it is. Give me your answer to 1 decimal place. Okay, done. In a single revolution of the wheel P is below the water level for a total of t seconds. According to the model, find the value of t, giving your answer to 3 significant figures. Right, let's have a go at that. This is going to be when 3 minus, was it minus or plus? 2 root 5, where is it? There it is, cos 0.5 equals to 0. Did I write that out right? Yes. I'm going to get 2 values because it's when it goes under. So it's like it's spinning round. It equals, so the height equals 0. That's when it first goes into the water. When it then equals 0 again, that's when it comes out of the water. So I'm going to get 2 values and then I'm going to look at the difference between them. So let's have a go at this. Take away 3 and then I'm going to divide by 2 root 5. Minus 3 divided by 2 root 5. So cos to the minus 1 of this. And then I'm going to take away this and then divide by a half. But I'm wondering if I should work out those values first. Cos to the minus 1 of minus 3 over 2 root 5 is 2.3. .306, and I'm going to need another value. So if that's my first one, again looking at my graph, we can see if that's 2 pi, wherever that value is, I need to do 2 pi minus it. So 2 pi minus 2.306 equals 3.977. So those are my 2 values. This is my first equation. Second equation I'm going to write now. So equation 1, t is going to equal 2.306 minus 0.464 divided by 0.5, which has given me 3.684. Second one, 3.977. Take away 0.464 equals, divided by a half, has given me 7.026. So then I do 2 take away 1. So I'm doing this, take away this, and I have got 3.342 seconds. Did it matter what we rounded it to? 3 significant figures, so let's take away that 2. And we're done. Part C, are we on? Part D. In reality, the water level might not be of constant height. Explain how the equation of the model should be refined to take this into account. Well, that's going to be this value here, isn't it? Because that was our starting height, so at 3 was our water level. So if they're saying that that's now going to vary and it's not going to be a constant height, then that 3 should also vary. So I'm going to put 3 should vary with the water level. Done. So the examiner report said that this question discriminated well between candidates that got this far, but it did appear that many candidates had simply run out of time. How frustrating is that? Perhaps indicative of a general lower understanding than in the June series because of it being a resit paper following the pandemic. So it could have been that, people running time, rushing through and not being able to answer this question. Which is a shame because I would say that this question was maybe easier than some of the earlier questions. But if you've got this far, please subscribe to my YouTube channel and leave a comment letting me know how you got on.